Hello, PreCalc. This is for Thursday after class, so it'll be the 27th, and we will be changing our strategy from little puzzles. So up till now, I've been giving you an expression and I've been saying simplify this expression. So this time, we're going to verify trig IDs. And remember, the word identity means two things are identical. So if you have your identity in Christ, you are like Christ. You equal Christ. And if you have your identity in sports, then you equal sports, and so forth. So these trig IDs are going to have equal signs in them because something equals something. So instead of simplifying trig expressions where there's no equal sign, I'm going to be verifying trig identities where there are equal signs. So example, write these down. So here we have example number 1, and you can see already that there is an equal sign. Like before, I would have given you this expression and not this one, and I would say simplify, and you would have come up with this one. Now I give you the answer, so what I want from you is all the steps in between to get from here to here. So let's go ahead and, at least in verifying trig IDs, this is a trig identity. This does equal this. So now I know that I start here and I end here. So it's a step easier, I think, than simplify. Because the simplify, you have to decide what direction to go in and where to stop. This tells you at least what the end line looks like. So keep an eye on the prize and let's go for it. The first step in this kind, where you're verifying trig IDs, is to take the left side and rewrite it. So you have that. And now we got to think of an example, or think of a step from our toolbox. So I'll put the toolbox up, at least a brief version of our toolbox. There's adding. When I say adding, that means give the same denominator and add. There's factoring. There is substitution using trig IDs from our list of 20. And there is change the sign and cosine. Alright, those are the big four that we have been pulling out of our toolbox to do these. So I'm going to observe this, and it looks like one of those Pythagorean IDs. So if I happen to be somewhere where I don't have my comp book to look at my list, I know this one by heart because it sticks easily. So sine squared plus cosine squared equals 1. But whenever I have a 1 and some trig function squared, I think to myself, it's probably one of the Pythagorean IDs. So I'm going to come up with the other two by dividing each of these by sine squared in my head. So if I divide this by sine squared, this by sine squared, and this by sine squared, that says cosecant theta. And that is one of the trig IDs. And now I'm going to go back to the first one and divide everything by cosine squared. So that gives me this. Cosine squared divided by cosine squared. Alright, so now I see this trig ID has sine squared, secant squared and 1 in it. So I'm going to move the 1 to the other side. And now I see exactly this expression. So I'm going to go ahead and substitute because secant squared minus 1 is tangent squared. Alright, so this is going to be this equals, so now I'm going to do another, take something else from my toolbox and create another ID and see if it's this. Keep going until it is. So, what can I do? I think there's nothing to add, there's nothing to factor. Let's try changing everything to sine and cosine. So tangent is sine over cosine. It's so important. The only way that you will enjoy these at all is to know those basic trig IDs so that they'll go quickly and your recognition will be sharp. So sine squared over cosine squared is tangent, and secant squared is 1 over cosine squared. So when you divide this fraction by this fraction, you end up multiplying both the numerator and the denominator by the reciprocal of the denominator. So anything divided by itself is just a big fat 1. So the denominators are gone. So some of you say, when you divide a fraction by a fraction, you just flip it and multiply. But this is why that works. I prefer the y part. So then this cosine will cross out this cosine, because they are factors, and 1 is in the numerator and 1 is the denominator, so they create a 1 as well. And so we have a big fat 1 this way, and what's left? Lo and behold, sine squared. So that's where we were headed, and that's where we got. Alright, so I am just going to briefly introduce this to you and give you one to do, because we're still working in class on simplifying trig expressions. This tells us where we're going to go to next, but I'm not sure we're ready to dive into it very deeply tonight. So let's just go ahead and I'll give you one, I'll give you a few hints on it and see if you can take it from there. Alright, erasures. I want you to verify for me that tangent squared theta plus 1 times cosine squared theta minus 1, when you multiply those together, you get negative tangent squared theta. Alright, so starting, first step, you're going to rewrite this left side exactly as it is, putting an equal sign. Then you're going to keep an eye on the prize, and you're going to go ahead and make some sort of either addition, factoring, substitution, or change to sine and cosine. So looking at these two expressions, I would think that I would look at this list here, the trig IDs and their various forms. So look at this list here and see if you can't make both a substitution here and a substitution here. Then, I wouldn't be surprised if you wouldn't have to take that result and change everything to sine and cosine and see what comes out in the end. Alright, so that's your challenge. Write it in your comp book. Give it a try. See if you can get this left side to be negative tangent squared. Alright, that's it for tonight. Short and sweet. See you tomorrow.